Okay. We have been seeing about the different components of the Hadoop ecosystem. So the last session we did discuss about the Hadoop distributed file system. So what is the purpose behind the various features of the Hadoop distributed file system? And we did also try to work out multiple choice questions and also descriptive questioning on how exactly different features of the Hadoop distributed file system complements the Hadoop ecosystem, how Hadoop distributed file system acts as the foundation for the system. Now, we will try to understand about the other components of the Hadoop ecosystem. So before we dive into what Hive is, let's understand the problem it was designed to solve. So we are all aware of big data, massive volumes of structured and unstructured data. Hadoop provided the foundational technology to store and process this data across clusters of commodity hardware. However, the primary way to process data was by writing complex Java programs called MapReduce jobs. So this created a major bottleneck. You needed to be a skilled Java developer to get insights from your data, leaving a huge community of SQL savvy analysts unable to work with. So there was a clear need for a bridge. So this is where Apache Hive comes in. Developed initially at Facebook, Hive was created to solve this exact problem. Think of it as a data warehouse layer on top of Hadoop. Its key feature is providing a familiar SQL-like language called IQL. This was a game changer. Now, anyone with SQL skills could write queries to analyze massive data sets stored in Hadoop. Hive takes your SQL-like query and does the hard work of translating it into an execution plan, like a MapReduce or a more advanced test or Spark job that can run on the Hadoop cluster. It's crucial to remember that Hive is not a replacement for traditional databases like Oracle or MySQL. It's designed for large-scale analytical queries, not real-time transactions. So Hive is an SQL-like high-level language used to run queries on data stored in Hadoop. It enables developers not familiar with MapReduce to write data queries that are translated into MapReduce jobs in Hadoop. Like Pig, Hive was developed as an abstraction layer, but geared more toward database analysts more familiar with SQL than Java. Hive provides a data warehouse infrastructure system for Hadoop, which creates a SQL-like wrapper interface for HiveQL on top of MapReduce. Hive can be used to run some of the ad hoc querying and basic aggregation and summarization processing on the Hadoop data. HiveQL is not SQL 92 compliant. Hive was developed by Facebook and contributed to patch as discussed earlier. Hive is designed on top of MapReduce, which means a HiveQL query to MapReduce jobs for processing it. You can even extend the HiveQL to user-defined functions. I hope you got an idea on how did this all start, the purpose behind this particular language. So let's look under the hood. When you submit a query through a client like the command line, it first hits the Hive driver. The most critical component here is the metastore. This is a database, often MySQL or Postgres, that stores all the schema information, what your table looks like, where the data files are located in Hadoop distributed file system, how they are partitioned. It's the catalog of your data warehouse. The driver then passes the query to the compiler, which creates a logical plan and optimizes it. Finally, this plan is sent to an execution engine. This could be the original MapReduce or more modern and faster engines like Taze or Spark, which actually process the data on the cluster. So with that said about Hive, let us see some of the features of Hive. So one, it stores schema in a database and processes data into Hadoop distributed file system. It is designed for OLAP. So I want you to find out what is this OLAP. So another one feature is it provides SQL type language for querying called HiveQL or HQL. The final feature is it is familiar, fast, scalable, and extensive. So these are some of the significant features of component Hive. So it's common to ask when should I use Hive and when should I use a database like MySQL. The table here you can see clarifies that. So they are designed for completely different words. Use a relational database management system for your web applications backend, where you need fast, real-time reads and writes for individual records. Use Hive for analyzing massive historical datasets, running complex analytical queries, and business intelligence reporting, where query response time is measured in minutes, not milliseconds. Comparison on Hive with traditional relational database management system, that is MySQL, an example. So let us see the features of each of these and the two comparison, that is attached Hive and traditional relational databases in different problems. The first feature about primary use, batch Hive is batch processing, data warehousing, which is OLAP. With respect to the traditional relational database management system, that is MySQL, its real-time transaction is the primary use, just OLTP. Next feature is data volume. With respect to Apache Hive, it is in petabytes. In regards to the traditional relational database management system, that is MySQL, it's gigabytes to terabytes. We are talking about the data. Next feature is schema. Apache Hive schema is on read, which is flexible. The schema on relational database management system MySQL is on write, which is not so flexible, so it's strict. Another feature is latency, which is high with respect to Apache Hive. So it's minutes to hours together. With respect to relational database management system MySQL, the latency is low, which is only in milliseconds. So the updates with respect to Apache Hive, it's limited or complex, no row level updates actually. The updates with respect to the traditional relational database management system MySQL, it's full CRUD. CRUD is create, read, update, delete. And the final feature, read or write, so which is one with respect to Apache Hive, write once, read many times. The traditional relational database management system, MySQL, is read and write frequently. So this table clearly shows on how exactly Apache Hive and the traditional relational database management system, like MySQL, is different with respect to these features listed out, like primary usage, data volume, the schema they follow, the latency, updates, and the form in which or the way in which they do this read file. So let's take or understand how exactly companies use Hive. It's a workhouse for ETL, extracting raw data, transforming it with Hive fuel, and loading it somewhere else. It's the go-to tool for ad hoc data exploration. Many business intelligence platforms have connectors for Hive, allowing them to build reports on top of petabyte scale data. And it's perfect for log analysis, shifting through huge volumes of machine generated data to find patterns. So ETL pipelines for large scale data transformation and cleaning before loading into another system. So data querying that is empowering analysts to explore large unstructured data sets without needing to be Java programmers. Business intelligence has the backend for business intelligence tools like Tableau or business intelligence to generate reports on massive datasets. Log analysis is processing and analyzing terabytes of web server logs, clickstreams data or application logs for user behavior analysis. So these are the space where exactly organizations utilize this particular component Hive. Now let us move on to the next component, that is HBase. So HBase is a column-oriented NoSQL database built on top of Hadoop distributed file system. HBase is used for fast read-write access to large amounts of data. HBase uses Zookeeper for its management to ensure that all of its components are up and running. HBase is a sorted map which is sparse, consistent, distributed, and multidimensional. HBase provides faster lookup and also high volume inserts or updates of random access request on a high scale. The HBase schema is very flexible and actually variable, where the columns can be added or removed at runtime. HBase supports for low latency and strongly consistent read-write operations. It is suitable for high-speed counter aggregation. Many organizations or companies use HBase such as Adobe, Yahoo, Twitter, StumbleUpon, NG Data, InfoLinks, Trend Micro, and many more organizations. So, on the whole, in these organizations, this is where HBase comes in. It's a NoSQL database, meaning it doesn't use the traditional table and row structure of SQL systems. It was inspired by a groundbreaking paper from Google on their big table database. Crucially, HBase is part of the Hadoop ecosystem and runs directly on top of Hadoop distributed file system, giving it massive fault tolerance and scalability. The simplest way to think about it as a giant sorted up map that's spread across many machines, allowing for incredibly fast lookups. A column-oriented NoSQL database built on top of Hadoop distributed file system, HBase is used for fast read or write access to a large amounts of data. It is extremely vital to understand HBase tables consist of a table, which is a collection of rows, row identified by a unique row key. Rows are sorted lexicographically by this key. Column family, the logical and physical grouping of columns must be defined at schema creation. Column qualifier, a specific column within a family, it can be added dynamically. Cell, the interaction or the intersection of a row and a column containing a value. Timestamp, each cell is version with a timestamp. HBase can store multiple versions of a cell. So this is the clear detailing about what exactly the tables of HBase comprise of. That is the rows, columns, column qualifier, the cell, and the timestamp. So the vital aspect you need to keep in mind is the HBase table is very different from an SQL table. Everything is centered around the row key, which is the only indexed field. Rows are sorted by this key. Columns are grouped into column families, which you define upfront, but within a family, you can add new columns on the fly without changing the scheme. This makes the tables sparse. A row doesn't need to have value for every column. Finally, every single piece of data is versioned, allowing you to see historical values. So HBase excels when you need these aspects. That is starting from massive data sets, tables with billions of rows and millions of columns, high write throughput, ingesting streams of data from logs, sensors, that is Internet of Things, or user events, real-time random access. The primary requirement is fast key-based lookups, not table scans, not full table scans. Schema flexibility, the data structure evolves over time, so automatic sampling and high availability. You need the database to scale and handle failures automatically. Example, Facebook Messenger, Pinterest content discovery, and analytics with these. So you can ask when exactly HBase needs to be chosen. It shines when you're dealing with truly massive tables. Think about having billions of rows. It's fantastic for high volume write scenarios like logging every click on a website or collecting data from thousands of Internet of Things devices. The key is that your access pattern should be based on looking up individual records or small ranges by their key. If you need to run complex analytical queries across the whole dataset, other tools like Hive or Spark are a better fit. Many large tech companies use HBase for exactly these type of problems. So before we move on to the next component for big data, it is MapReduce that was the primary tool for big data prior to this part. While revolutionary, it was slow because it wrote intermediate results to disk after every single operation. This made complex, multi-step jobs and interactive analysis painfully slow. At its lowest level, Spark operates on a concept called RDDs, so resilient distributed data sets. Think of an resilient distributed data sets as a read-only collection of items distributed across cluster. Its resilience is key. It can recover from failures without user intervention. So a high performance processing framework for in-memory analytic computational processing that is often used for real-time querying. So Spark is a high performance processing framework for in-memory analytic computational processing that is often used for real-time querying. Spark provides a powerful alternative to Hadoop's MapReduce. Apache Spark is a parallel data processing framework that can run programs up to 100 times faster than MapReduce in memory or 10 times faster on disk. Spark is used for real-time stream processing and analysis of the data. The high-performance processing framework for in-memory analytic computational processing that is often used for real-time querying. Spark provides a powerful alternative to Hadoop's MapReduce. Its programming follows more of the directed acyclic graph, which is DAG pattern, in which multi-step data flows and is complex, which is explained in the figure. So in this figure, you can see it's a high-level look of Spark's architecture. So you can see there is an input and the iteration 1, then the iteration 2. You can see in comparison, you have the Hadoop architecture, wherein the input, the Hadoop distributed file system read, Hadoop distributed file system write, and again Hadoop distributed file system read in iteration 2, and Hadoop distributed file system write. So your code runs on the driver talks to a client manager to get the resources, cluster manager provides executors on worker nodes. These executors are the hands that do the actual computation slices of your data. So Spark has numerous features and capabilities worth mentioning as follows. So let us look at the features. So it can process iterative and interactive analytics. Many functions and operators are available for data analysis. DAG framework to design functions easily. In-memory based intermediate storage is possible. It's easy to use and maintain. Also, it is written in Scala and runs in Java virtual environment applications using Spark, Scala, Java, Python, R, usually. So it runs in environments such as Hadoop and resource or standalone as well. So you can ask the purpose behind choosing Spark. So these are some of the reasons behind choosing Spark. To begin with, the speed. In-memory processing makes it orders of magnitude faster for many workloads. Ease of use, it's simple, high-level application programming interfaces in popular languages that reduces development time. Unified platform, one framework for batch, streaming, SQL, and machine learning. It reduces the system complexity. Flexibility runs everywhere on Hadoop, Mesos, Kubernetes, standalone, or in the cloud. Huge community, actively developed and supported by massive major companies like Databricks. So these are some of the reasons, like starting with the speed and ease of use, unified platform flexibility for choosing Spark. So Spark isn't just academic, it's the engine behind critical applications at the world's biggest companies. From the recommendations you see on Netflix, financial fraud detection, Spark is working behind the scenes. So let us see who else uses e-commerce. That is, who else uses Spark. Starting with e-commerce and media. So as we have mentioned, Netflix and eBay. So they have this real-time recommendation engines. User who watch this also watch the photo. So you will get some recommendations like that wherever you go, and also audience segmentation and ad targeting happens in the e-commerce portals and even in the media platforms. Next is finance. So Goldman Sachs, Capital One. So real-time fraud detection and anomaly detection, risk analysis and trade settlement analytics can be done with this Spark tool. Internet of Things, processing and analyzing massive streams of sensor data from smart devices, industrial machineries. They can really help out users to understand the pattern and process that and take it further for additional detailing or analysis. Next, in the field of healthcare and genomics, accelerating genomic sequencing and drug discovery research, Apache Spark really helps a lot there. So we have understood about the reason behind using Spark, what is Spark all about, various features, the architecture, how exactly it differs with the other aspects of the MapReduce, how Spark has been used in different organizations, in different portals. Now, let us try to solve this MCQ questions. And one question is about which of the following is a primary use case for Apache HBase. Another question is which jobs are optimized for scalability but not latency? So we've seen topics about Hive, HBase, and Spark. So go ahead, solve these two questions. So let us take some 3 minutes of time so that you can try and solve them. We have solved one question. We can move on to the next one. Last 1 minute to solve these two questions. So let us start with the first question. Which of the following is a primary use case for Apache HBase? So the options are batch processing of large data sets. The second option is real-time read or write access to big data. The third option is data warehousing in analytics. And the fourth option is stream processing of live data. So the primary use case as per the understanding is real-time read or write access to big data. That should be the right answer. It's not about batch processing of large data set or data warehouse. It's the real-time read or write access to big data. The next question is, which jobs are optimized for scalability but not latency? So the options are map reduce, drill, receive, and Hive. So optimized for scalability but not latency. The right answer will be MapReduce. So MapReduce jobs are optimized for scalability but not latency. So I hope you got the answers right. So these two questions have been taken from the content that we have reviewed in this video. So let's move on to the final slide, that is the references. So you can try and get additional information on this specific topic on the different components of Hadoop ecosystem, that is HBase, Hive, and Spark. So we did understand how Hive contributes to this Hadoop ecosystem and how exactly the organizations use Hive and how exactly it's different from the traditional relational database management system, like SQL. We also did see about HBase and different features, how exactly it differs. And finally, we did discuss about Apache Spark, how exactly Apache Spark is different, uh, how it has evolved when you compare it with MapReduce, and how exactly it has been utilized in many organizations, media portals, so that customers are able to utilize the applications with such advancements. So with that, we come to the end of this particular topic. Now, in the upcoming sessions, we'll try to see some more components of the Hadoop ecosystems. And thank you for your patience and viewing this video on this specific topic.